Hello and welcome to this directory server web training session. Over the next few months, the training department will be holding several short overview sessions for each of our products, and this seminar is the first of those. In this session, I'll be taking you through some of our technical support department's recommendations for the optimal performance and safety of your directory server installation. This webinar deals with three topic areas for the directory server. First, we're going to talk a little bit about how to protect your data from disk or system failure. This involves the backup and restoration commands and also describes the different types of backup that can be taken. Next, we look at monitoring the system, which is getting an understanding for how the system should work, and through active monitoring being in a position to know when and if the performance of the directory server is less than optimal. We'll then talk briefly about the importance of keeping the system up to date via the application of patches and let you know how and when you need to get them. The first topic covered is the need to protect your data. The data that needs to be protected falls into two categories: the physical data itself, which is included in the files ds.d.00 and the ulogs directory, and also the configuration items, which determine how the processes that allow access to the data will work. These include the exec file, which describes the starter parameters for the processes which allow access to the data. The OIDS local file contains schema element definitions, and the file backup.control controls the options for backing up the system. If you want your DSA to work in exactly the same way after it's restored, you will need to back up each of these files. When determining how often to take backups and what kind of backups should be taken, there are two key factors to consider. Question 1. How often does the data change? When the data is recovered, data is taken from a snapshot of the state the data was in when the backup was taken. Any changes that were made to the system between backups are stored in update logs, and once the data is recovered, those updates are applied to the snapshot to restore the directory to the state it was in when failure occurred. If, for example, you have many changes every day, it will be far quicker to recover from yesterday's snapshot and apply 1 day's worth of updates, as opposed to recovering from last week's snapshot and applying up to 7 days worth of changes. This leads us to our second question: how much downtime can be tolerated? While these updates are being applied, the DSA will be read-only. Therefore, if you have a lot of changes, you should consider a full backup every day. Backups will usually complete in under an hour, and the majority of customers schedule backups overnight where there is very little load on the system. While the DSA is being backed up, it is temporarily frozen for write updates, but all update requests will be queued, so will be applied once the database is unfrozen. If we take the example of a company which has a DSA receiving about 5,000 updates per day, at the moment they do one weekly backup on a Sunday night when traffic is low. All update logs are maintained on the same disk as the live DSA. Imagine now that this company suffers a disk failure on a Thursday evening. To recover this data, they would then have to recover the full backup taken on Sunday night. This backup contains all of the data that was in the DSA when the snapshot was taken. Next, we need to apply the updates. It may very well be that in the event of disk failure, the update logs are lost as well, but assuming they are not, they will be applied to the snapshot. In this case, we have 4 days worth of updates to apply, roughly 20,000 operations. The DSA will be frozen for updates while these updates are applied, and while any indexes are rebuilt. In this case, it would have been far quicker to recover from a more recent backup, which would also ensure that the update logs are retained in the case of catastrophic disk failure. Incremental backups can also be taken, which record only the differences between the last full backup and the current system. In this case, a weekly full backup followed by daily incremental backups would be ideal. The time taken to create the backups is balanced against the required recovery time. The command used to kick off a backup is odsbu. odsbu is a command line utility, so it must be run as the user who owns the DSA software, for example, the DSadmin user. The default behavior of the odsbu command, if called with no parameters, is to take a full backup of the DSA in the current working directory. You can also configure other behaviors for the ODSBU utility through the command line parameters. For example, to configure the default storage location for backups, we use the -D option. This will ensure that future backups will be stored in the specified location, and any existing backups will be moved there. Make sure that the directory already exists and that you have right permissions for it. -N sets the amount of backups you want to store by default. Backups will never be removed by ODSBU unless you've specified you want to remove them. You can do this using the -T option. If you have specified that you want to keep the last 5 backups, and you have 5 backups, ODSBU -T will create a 6th backup and remove the oldest backup in the list, leaving 5. If you want to remove older backups without taking a new backup, you can use ODSBU -X. Using ODSBU -I will create an incremental backup, a copy of the changes between the newest backup and the current system. And using the -C flag will add a comment to the list of backups. On this slide I have a number of examples of the usage of ODSBU. The first command, ODSBU on its own, will take a full backup of the directory contained in the current working directory. The second command takes an incremental backup. For this to happen, we must first have a full backup. The third command configures the storage location for backups. Please note that this doesn't generate a new backup. It just tells the system to move all existing backups to the directory specified by the -D flag, and to create any subsequent backups there. The fourth command tells the system how many backups you want to keep. Again, it does not take a new backup, nor will the system ever delete backups without you telling it to.